Hello. Today we are going to look at common factors and grouping factors. Now factorizing is kind of the reverse of multiply, and we're going to see that in a minute. But we've come across the idea of factors lots of times before, where we would have, say, the number 12, and we would break it up into 3 multiplied by 4, or 2 multiplied by 6. Those would be factor pairs of 12. And in algebra, we do a very similar thing. We could break up our different terms in our algebraic expressions into different factors. So say 6x could be broken up into 6 multiplied by x, or it could be written as 2 multiplied by 3x. We can break it up into its factors. And the first and most important type of factorization we do in algebra is called common factors, which is where we say, well, this term has factors and this term has factors. Are there any factors in common? Is there any factor that is common to all of the terms that we're interested in? That's the first type of factorization we always try. We're going to learn a bunch of different methods for factorizing, but common factor always comes first. So common factor comes first is a rule of thumb that should be in the back of our minds moving forward with algebra. So, is there a common factor to these first two terms that we're dealing with in this expression? Well, there is. 3 is a factor of 6, and 3 is a factor of 9. So 3 is a common factor to both of these terms. There's no common factor of the letters in this case, but there is a common factor of the number 3. So what we're going to do is write down the number 3, write down our common factor, and open up a bracket. And the next thing we're going to do is divide this common factor into each of these terms and write them inside the bracket. So let's start off with 6x. 6x divided by our common factor of 3 is going to be equal to 2x. You don't need to write this extra bit down if you don't feel you need to, but if you're making mistakes or if you're finding this difficult, this is a great aid to help us if we do our division out explicitly. So we get 2x, and then 3 divided into 9y. 9y divide 3 is going to leave us with 3y. So then plus 3y. Now, why do we do it that way? Because, as I say, factorizing in algebra is kind of the reverse of multiply. So if I multiply out this bracket now, this is not part of factorizing, this is to show you why we did it in the way that we did. 3 by 2x is 6x, and 3 by 3y is 9y. So the factorizing is kind of the reverse of multiply. And it's very useful for being able to see patterns in numbers and lots of different things that we're going to need, and to simplify expressions. Let's get some more practice. So now we have these two terms here. What's the highest common factor of our numbers? Well, it's 7. The highest common factor of 7 and 14 is 7. Highest common factor of x squared and x, well, x squared would mean x multiplied by x. So the largest number of x's that are common to both would be x to the power of 1, or just x. And then we have y to the power of 1 for both of them, so it is common to both as well. So now we have our common factor. Let's deal with our bits that have to go in the bracket. So I have 7x squared y divided by 7xy is equal to, well, the only thing that it doesn't get divided out to 1 will be x. So that's x. And then we have minus 14xy divided by 7xy. And we are left with minus 2. So we have minus 2. And again, if we'd multiply that out, we'd get back our original expression. Let's go on to this one. So we have 18a squared y to the 4 minus 6a squared y cubed, or to the power of 3. Highest common factor of our numbers is going to be 6. Highest common factor of our a's is a squared. Highest common factor of our y's, well, I have 4 y's multiplied together here and 3 y's multiplied together here. So in total, sorry, not in total, the largest number that are common to both would be y to the power of 3. I have 3 y's multiplied together here and 3 y's multiplied together here times another y. So that's my common factor. And I'm not going to write my division this time again. You can if you find it useful. This is how we can give ourselves help if we're finding it challenging to figure out what the numbers in our bracket should be. That's how we would do it. Divide our terms by our common factor. So here we are going to end up with 6 goes into 18 3 times. A squared divided into a squared is 1. And y cubed divided into y to the power of 4 is going to leave us with y. And then 6 goes into 6 once. A squared goes into a squared once. Y cubed goes into y cubed once. So we're left with minus 1 in our bracket. Now, if we get a bunch of terms, the first thing we still check is, do I have a common factor to everything? And no, I don't. So what I'm going to do next is, can I take a common factor from the first 2 terms and then the second 2 terms? And I'm going to try that first. When I see I don't have a common factor, that's the next thing I try. So do I have a common factor to my first 2 terms? I do. There's an x in both of them. So let's take an x and then write in what's going to go in. X into x, y is going to leave us with y. X into minus 4x is going to leave us with minus 4. And what's common to my second 2 terms? 3 is common to my second 2 terms. And I'm going to take out a plus 3. So now I want to divide that in. So I end up with 3y divided by 3 is going to leave me with y. And 3 divided into minus 12 is going to leave me with minus 4. But I can go further, because we might be able to see this whole bracket is now common to both terms. So this whole block here with the bracket multiplied by the x is a term, and this whole bracket here with multiplied by the 3 is a term. And I can see that I have y minus 4, the bracket y minus 4, is in both of those terms. So it itself, the bracket, is a common factor. So I can write it down as a common factor. So I write down my common factor, and I open up a bracket. I say, if I divide this into this, I'm going to be left with x. And if I divide this into this, I'm going to be left with plus 3. Now, I'm just going to do that out the long way, like I did here, just to make sure everyone's okay with it. X all over y minus 4 divided by y minus 4. Well, if I have y minus 4 divided by y minus 4, that divides out to 1 and 1. Any number, no matter how weird it looks, divided by itself will just be 1. So I'm left with x. And I can do the same thing for my 3. So this is the extra logical leap we have to make for these longer questions. So let's practice them a little bit more. So I have 2q or minus or s minus 10pq plus 5ps. So I'm going to try taking out a common factor here, a common factor here. So I look for my common factor here, and or is the only thing that's common there. So I end up with 2q minus S. What's common here? Well, I have a 5 common to the numbers, and I have a P common to my letters. So I end up with plus 5P. And then I end up with minus 2Q plus S. And I have a problem. I want to have, like what I had here, the same thing in both of these brackets, but the signs are wrong here. The terms look okay, but the signs are wrong. So what could I do instead of taking out a plus 5? Well, if I take out a factor of minus 5p, minus 5p divided into minus 10pq, minus divided by minus will give me a plus, and then I end up with 2pq, and minus divided by plus will be minus, and I'm left with s. And now I have the same thing in both of these brackets. So sometimes we need to be clever and take out a negative factor in order to get the signs the same in both brackets. So we write our common factor, minus 2pqs on or minus 5p. Let's practice this one. So I go here and I try to take a common factor from here and a common factor from here, just like I did before. But 1 is the only common factor in these terms, and 1 is the only common factor in these terms, and that doesn't get me very far. So I've run into a problem. I need to go back. I can't do what I want to do, so I have to improvise. Is there any common factors I can see? Well, there's a common factor of B in the first two terms, and there's a common factor of A in the outside terms. So could I take common factors from them instead? And I can. So let's take a common factor of A from the outside terms. Then I'd have 3 plus x. And then there's a common factor of B here, so plus B. And I'm left with x plus 3. And happily, this is the same thing. A plus B is the same as B plus A. Poor choice of letters. X plus Y would be the same as Y plus X. So we can add stuff in any order we like. So this is the same as this. So then I can take that out. My common factor multiplied by A plus B. Finally, again, we always look for common factor comes first. So I can see there's a common factor here of 2. So I'm going to take out my common factor of 2. And then I go on from there. So I need to be conscious. Always look for common factor first. Common factor comes first. Minus P. So I've now taken out my common factor. There's no common factor that I can see for the first two terms. Is there? Nope. There is for the second two terms, but I can't see anything for the first two terms. So I'm going to have to try and take from the two terms in the middle and the two terms on the end, just like I did in the last case. So then I have 2. I'm going to have my common factor of my outside terms is going to be P. And I end up with 3P 3P minus 1. And then my common factor of my second two terms will be 2 plus 2Q. And I end up with 1 minus 3P. And I run into the same problems I had last time. I need to change my signs. And when I've done that, I can then take out my common factor of my 3P minus 1, and I have my final factorization. And that's what we need for now.